Probability 1, introduction. We deal with probability almost every day. And whenever we talk about a chance of rain or a chance to win a lottery, that is about probability. Probability was driven by gambling, and the theory of probability is deep and rich, and people can take many courses to study more about probability and do research about probability. But here we introduce probability to make use of combinatorics. So we will talk about some terms of probability. And probability is to provide a measure of chance that an event could happen. So, and for example, when we roll a die, what is the chance a 6 will show up? So now let's look at the terms. So first, we make a table format. So here we talk about a term, and then here we talk about the example. So first term is called a probability experiment. So the example will be like rolling a 6-sided die. A probability experiment is a repeatable process whose outcomes are uncertain. So it's important that it should be repeatable and the outcomes are uncertain. If that's not the case, then it's not called a probability experiment. And then we have another term, it's called a trial. A trial is each repetition of an experiment. So, and then each time we roll a die, that it's called a trial. And then when you roll a die, and you will see an outcome. So that's what we mean by an outcomes. So that would be the possible results of the experiment. So when you think about rolling a die, the possible results could be 1 show up, or 2 show up, 3, 4, 5, 6. So these are possible outcomes when we roll a 6-sided die. And then sample space. Sample space is the set of all possible outcomes. So in this case, that would be the set of 1, 2, 3, 4, 5, 6. So that is a sample space, and we often use S to denote a sample space, and then we use cardinality, in this case, is 6. And then we have called an event. So an event is a subset of the sample space. So in this case, for example, a subset of this, a single element is a subset, so this is a event. Or you can say 1, 2 elements, that is a subset, that can be another event. Or you can also say the event of 1 or 2, union 2. So that would be another subset of S sample space. So this can be another event. So event is a subset, and event is a subset of sample space. Now mathematically we define an event by a subset, but a subset can be quite descriptive. So let's look at this description here. For example, if we take the event of rolling a die, and then we take the subset 1, then this one can be described as the chance that 1 will happen. So this is descriptive. But if you look at 1 union 6, so that means 1 or 6 will happen. So then this event can be described as the chance to get 1 or 6. So you can see it is quite descriptive, And in the book, you also see more examples how we describe an event by a subset. To find the probability, it is very important to understand how we describe the sample space and the event. So let's look at another example how we describe sample space. For example, find the sample space of the following experience. First one, rolling a 6-sided die, and just now we actually described here. So the sample space for this experience is a set of 6 natural numbers, 1, 2, 3, 4, 5, 6. So that is the sample space. And let's look at the second one, tossing 3 coins. So if we have 3 coins and we tossed it, then each coin could show a head or could show a tail. So what is the sample space that we for this experience? So that will be, so you could think the first coin you have can show a head or can show a tail. That's the first coin. And then if the first coin show a head, then for the second coin, you could get a head or you could get a tail. Or if the first coin show a tail, then you could get a head or you could get a tail for the second coin. And then for the third coin, for each case, you can get a head or a tail. So this one you could get a head or a tail, or this one a head or a tail, or this one a head or tail. So therefore, a possible outcome for tossing 3 coins, you could get 3 heads for all the coins, or you could get head, head, tail, or you could get head, tail, head, and go this one, that will be head, tail, tail. And this one, you get tail, head, head. This one you get tail, head, tail. And this one you get tail, tail, head. And the last one you get tail, tail, tail. So the sample space of tossing 3 coins are all these 8. 1, 2, 3, 4, 5, 6, 7, 8. Yeah, 8 outcomes. So that is the sample space for these 3 coins. And to save time, let me just not copy everyone here. So that's the sample space. And then from here, you can determine the cardinality of the sample space is 8 because you have 8 outcomes, possible outcomes here. And then this example also shows us that, sometimes to determine sample space, a tree diagram will be useful. Now let's look at another example how we determine the sample space of an experiment. And this time, we selecting a car from the standard deck of 52 cards. So then the sample space, this is quite easy because you only have talking about 1 card taken from 52 cards. So the sample space, the outcome will be 52 cards. So that is the sample space. And then the cardinality is also easy to determine. It's 52. But let's look at a little bit harder one. Say selecting 5 cards from the standard deck of 52 cards. So if the experiment is selecting 5 cards from the standard deck of 52 cards, what is the sample space? So, well, the sample space is not difficult to describe, but how do we find the cardinality of sample space? So that means 5 cards. So each time you select 5 cards, this may not be very accurate. So it's 5 cards from 52 cards. So when we select 5 cards, if we want to find the cardinality, how many ways to select 5 cards? And to think about that, and when we select 5 cards, we don't really care about the order of how the 5 cards we take. So therefore, the order is not observed. But then this will be 52 cards taking 5 at a time, and the order is not observed. So this is a combination problem. So it will be combination of 52 taking 5 a time. You may use a calculator to find out what exactly it is. This number is very, very large. As for homework, please see assignment number 41. Thank you.